Hello, and welcome to lgtm on Cloud Native TV. Hello, and welcome to lgtm. I am your host, David Flanagan. You may know me better as Rock Code on the interwebs and Twitter. Before we get started today, please remember this is an official CNCF event and as such is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of that Code of Conduct. Basically, just be respectful of the fellow participants and presenters. Today, we're taking a look at OpenPolicyAgent and how to get contributed there, and I am joined by Torrin Heyman. How are you today?
Hey, David. Thanks for having me back.
Yeah, always a
Happy to
pleasure.
be back. I'm Torin. I'm one of the co-creators of the Open Policy Agent project. I work on all things OPA related, from the policy language and a bunch of the tooling and the integrations and the community and so on. So I'm really excited about this. And I'm also the VP of open source at Styra. We're the creators of Open Policy Agent.
Awesome. Well, thank you for joining me. OpenPolicyAgent is such a cool project. I'm always amazed at just how quickly it's growing. Has that caught you by surprise as well?
It's been a pretty exciting ride, especially the last couple of years. End user adoption has grown quite quickly, and just the sheer number of use cases I think that we see people leveraging it for. Not just Kubernetes admission control, which was one of the really popular use cases from back in the day, but all kinds of things. CI/CD enforcement, Terraform enforcement, microservice API authorization, all kinds of stuff. There's just a really cool long tail of use cases, and I personally find that really satisfying to see.
Nice. My next question was going to be, what is it? But I think you just kind of covered that. All right. Well, I'm looking forward to this. I'm going to pop my screen share up. And what we have here is the OpenPolicyAgent repository. So it's available at github.com/open-policy-agent/OPA. We are going to be taking a look at the directory structure and giving you a high-level overview of where all the code lives, as well as a few other tidbits to help you contribute to OpenPolicyAgent in your own time. Torrin, you are our guide for today. So where would you like to start in our wild journey?
That's a good question. When you mentioned doing this, I was like, oh, this is going to be great. And I realized, oh my God, there's a lot of things here. The project's been around for several years, and it's grown. So this is going to be fun. Why don't we just go up one level on GitHub to the organization first, and then we'll come back down in a second. Like you mentioned, David, you can get to the repo, to the organization on GitHub. One thing to keep in mind is that OpenPolicyAgent is a project that's sort of intended to enable policy enforcement across a wide range of different technology. So Kubernetes, Envoy, CI/CD systems, you name it, right? And so as a result, we have a bunch of different sub-projects that enable that, because OPA on its own can't really do much in the world. It's just like a language and an engine for executing that language. And so what we need are integrations that take OPA and hook it up to pieces of software and make it do cool things. And so that's what you kind of start to see here a little bit with these pinned repositories. There's a bunch of other repos that exist. There's the Gatekeeper repository, so that's our Kubernetes admission controller integration. There's the conf test repository. That's for using OPA to enforce policies on the command line, like inside of a CI/CD pipeline. You can really easily take your Rego policies and run them against config files, whether those are Kubernetes manifests or potentially like Terraform modules, or even Docker files, npm package JSON files, you name it, right? Any kind of config that you want to express guardrails against, you can use conftest to do that very nicely. Then there's the Envoy plugin, so that allows us to enforce API authorization policies, for example, inside of a service mesh by hooking up to Envoy's XAuthZ framework, and so on. And then you also see there's some IDE plugins there. So those are basically improving the authoring experience for working with OPA, working with Rego inside of VS Code, IntelliJ IDEA, and so on. And so the reason why I wanted to just call this out is that one of the areas where I see people be most productive when they start contributing to OPA is within these integrations. So if you have a need around policy enforcement inside of CI/CD, check out conftest. If you are looking at microservice API authorization, check out the Envoy plugin. If you're kind of running Kubernetes and you want to do admission control, check out Gatekeeper, and so on. And so there's a whole bunch of different ways you can contribute. It doesn't have to just be inside of the core repository. But yeah, so I just wanted to call that out. So let's dive back in though now into the OPA repo, I guess. This is, I guess, the oldest repo in the organization. And so there's a bunch of code in here. What the OPA repo contains is sort of like the lowest level bits of the OPA project, which are the implementation of Rego, the policy language. So that's sort of like the parser and the compiler and the evaluator. And then on top of that, there is a bunch of tooling, like command line tooling, so that you can interact with policies. So there's like a test runner, there's a REPL, there's a benchmarking tool, there's all kinds of stuff there. And then on top of the tooling, there's also everything that makes the server work, right? So when you take OPA and you deploy it into your environments, there's a server that runs, and it's got a bunch of functionality for kind of like operations, essentially, to manage those agents. So there's a whole bunch of code, there's a whole bunch of different areas that are covered inside of this repository. And we can kind of like start going through that. I guess, yeah, or maybe if we go down to the README, maybe there's some examples that we can just kind of talk through.
Yeah, let's take a look at that.
Yeah. So usually where people kind of get started is by building integrations, like I said. So there's a link there to the Go APIs. If you're taking OPA and you're embedding it into like a program written in Go, that's a really good reference. There's a bunch of examples in the Go doc that show how you can take OPA and hook it up to, or how you can call it, how you can invoke it basically from Go. The REST API is similar. It's sort of like if you want to integrate with OPA from another language, the best way to do that is by interacting with the HTTP API. And so that API reference is there for people. And then below, for contributing to OPA itself, we have kind of like two kind of like jumping off points. There's the development MD file and the contributing MD file. And those serve slightly different purposes. So the contributing MD file kind of explains like the overall process that you can expect when you want to contribute to OPA. And so we try to lay out like how you should go about contributing to the project. And so we kind of explain like when it makes sense to just open a PR right away versus when it makes sense to just file an issue. And that's just based on the kind of the scale of what you're interested in or what you're proposing, right? If it's a small feature or a small fix, like go ahead and open a PR. It's not no big deal. But if you want to do something more substantial, then we recommend opening an issue, and then we can have a discussion and we can talk about different options, because sometimes people don't realize all the options that are available, and so we find it's like useful to have that kind of conversation on issues.
I think that's really important. You don't want to invest too much time contributing a new feature that you think is the best thing ever and is really niche or only targeted to your individual use case. Like, it's always better to have that issue and open a dialogue with the maintainers and the contributors and even other end users to make sure that, yeah, people actually want this feature.
Yeah, and sometimes like people will have a feature that like we know other users are interested in, and so it can be just really useful just to have that issue up, because we can tag other users and ask them for their opinions and so on before we commit to a particular implementation. And then once we've decided to implement something, the rest of this document kind of explains some of the process around that and like where you can go, and some kind of like guidance on what we'd like to see from contributions. One of the development philosophies that we've applied since the very beginning is like this idea of like documentation driven development. So we try as much as possible to make sure that like all features that go in, all PRs that go in, have docs changes accompanying them. And if they don't have documentation changes, that's almost like that's almost like a not a red flag, but it's like, why not? Like what's the reason for that? Because at the end of the day, if there aren't any docs for the thing that you're adding, like no one's going to use it, and you don't want that. So we recommend think about the docs changes that you'll want to contribute, and then obviously we need to make sure that there's tests for everything. So we kind of like talk about that, and there are a few other kind of considerations we have. One of them is that it's a fairly like large project, and so one of the challenges we have is just ensuring stability and backwards compatibility for our users. There's a lot of people that are embedding OPA as a library inside of their own projects, and we don't always know what features of OPA they're going to use. And so we recommend, for example, just by convention, putting code under the internal package if possible, and not exporting it from the OPA project. So that way it can be used inside of OPA and it can be shared inside of OPA, but it won't be accessed by people that are embedding OPA inside of their own programs. And that way, like it's just really nice. It's like a kind of like a little kind of like safeguard that you have, when you're 6 months later, when you need to do some refactoring, you don't have to worry about breaking a bunch of people because you've decided to change some internal API.
I'd never really considered it that way before, but it makes a lot more sense. I don't know why I'd never thought of internal as a way just to kind of experiment and add new features. And then when they aren't stable, you could actually build it, like you could expose them via public APIs instead of having them by public by default. So.
Yeah, and I actually didn't even realize I wasn't aware of internal when we started the project. So a lot of the code kind of started off being exported, and then when I learned about internal, I was so happy. And it's funny, like it's kind of like a matter of taste. Like some people, I've had conversations with some people, and they're like, "Oh no, I don't want to do that. I want my code to be used by as many people as possible." I'm like, "Okay, well that's your decision." It's like for me personally, like I want to expose the minimum possible API, but I get it. So, but yeah, I love the internal packaging Go. It's such a nice, simple way of like organizing your code, and it's just like, yeah, I'm always happy when I go to make a change inside of one of the internal packages because I know I'm not going to break anybody.
Yeah, it's one of those things that if you've not been a Go developer for long, it can kind of trip you up, or you learn the hard way, like I did, where I was trying to use someone else's internal package. I'm like, why doesn't this work? And then you go down the rabbit hole of, like, oh, all right, okay, and then you go through.
It's very. Sorry, go ahead.
I was just going to say, I went down the path of, it's annoying. Why would anyone want this? This is the worst language feature ever. And then like 3 years later, I'm like, okay, yeah, there's value here. So.
Yeah, future you is thanking past you for, yeah. One of the other things we also try to, one of the other things we try to do is avoid pulling in like large third-party dependencies. And so this actually applies to built-in functions, which is one of the things we're going to look at today. We try to keep OPA, like the implementation, to be sort of as lightweight and easily embeddable as possible. And so, that's really nice for some people because they can kind of they can embed OPA in their project super easily, and we don't have to worry about dependency conflicts basically. And so. So we talk about that as well. So as much as possible, we say like rely on the Go standard library. That's probably okay. That's fairly stable. But if the thing you're trying to add requires some like big external library, we say, well, maybe there's another way of doing this, or maybe we could re-implement this particular feature, or maybe we could just vendor the code differently. So yeah.
Vendoring conversations with Go project maintainers used to be. Well, you never knew what you were going to get. These days, I think everyone's just settled on GoMod, right? Is OPA using? Yeah. Okay.
Yeah. We use GoMod. We're always wondering about like the stability and the backwards compatibility question. Like I feel like these days, like I worry about like scalability issues and backwards compatibility. Those are like the only two things I think about. But yeah, so it's always like a question of like, are these dependencies that we're pulling in going to be stable and reliable? Or are we going to have to like, are we gonna run into package conflicts with users and so on if we pull in some library? So it's an interesting balance for sure.
Yeah, it's nice that someone's worrying about that. I know that's I probably don't pay enough attention to those things as I should in my own projects. So at least not until they bite me on the ass, and then I'm like, ah, damn it. So, all right, you said there was this other guide here. So this is the development one, which is just telling us how to build the project.
That's right. Yeah. I don't know who like invented this like distinction originally. But yeah, there's this like idea of like the contributing MD is sort of like the process and the work like the for interacting with the project, and then the development MD is more like the mechanics for interacting with the actual code, right? So this is a good a guide, especially if you're kind of like new to Go, then I recommend this one because it was sort of written with that persona in mind. Like if you haven't never written any Go code, this is like probably a decent place to get started contributing to OPA because it doesn't make any assumptions about it doesn't make too many assumptions about
Yeah.
pre-existing knowledge. And so we try to go through a bunch of the different considerations here, like how you can vendor new dependencies, where the tests are located, and we actually explain kind of like roughly the pull request workflow as well. We just wanted this to be as kind of self-contained as possible. Not everybody is familiar with contributing to projects on GitHub, right? If you don't work on open source or projects, for your day-to-day job, or you don't contribute on your spare time, which is a totally reasonable thing to do, then it's nice to have a little bit of a guide because every project has like a slightly different kind of like workflow, I think.
Yeah.
So we just wanted to suggest like this is what we do. So yeah.
Yeah, I like this document. I like the no assumptions approach. I like that it just walks you through each of the processes. Like I definitely may borrow this for some of my own.
Well, feel free. That's one of the great parts about open source projects. One of the things that I think is actually pretty cool here, we added this a while ago down at the bottom. This was when we switched over from we originally used Travis CI for our all of our CI needs. Rip Travis. We eventually switched over to GitHub Actions. And when we did that, we made a bunch of improvements to the CI/CD or to our CI infrastructure. And one of those improvements was to kind of like externalize all of the I guess what you could think of as like options or parameters that are like kind of like dependent on external systems. So, for example, there's a Docker image that we built, and where that Docker image gets pushed to might be different if you're building this for your internal company or if you're trying to build a fork of OPA or something like that. And so this section just gives like a little table of all the options you can control on the build. And so I think it's pretty much, it should be possible right now. I haven't tested this lately, but it should be possible to like fork OPA, set these secrets to your own kind of like values, and then for it to just work basically. So you could basically clone OPA CI into your own GitHub Actions environment and have it just work. So if you wanted to create a full fork of OPA, you can do that, hopefully.
Nice. All right, let's. I think that those two guys are great, and I hope that our audience today gets a lot of value out of that, and I'm sure they will. Let's talk about someone has came along and they've read the docs. So okay, I feel like I'm prepared to start making a contribution. They go to the issue queue and they're maybe looking for some help because they don't have something they want to specifically work on. Is there any tips you've got for navigating the issues?
So the thing that the sort of convention we follow is that issues that are there's a label basically. So I think it used to be called low hanging fruit, but we renamed it recently to good first issue. Yeah, that's the one.
A lot of projects seem to be going down that route of the good first issue.
Yeah, I like low hanging fruit. It had this like kind of like ring to it, but I think that's not. It's not the most well understood term, and it's kind of like idiomatic for English speakers. So this is definitely better. So what we do when we're kind of like triaging issues that come into the project is that we look at them and we kind of make a decision about whether or not we think that somebody without any context for OPA really could make a contribution. And if we do think that they can make a contribution, then we tag it with that good first issue label. And so usually what that means is that the implementation required for this bug fix or this feature is pretty well understood. It's understood to the point where like I could write down, in a bulleted list or in a numbered list, like these are the files you'll have to change, these are the lines you'll have to change, and maybe I could go do that myself, but like this kind of gives people like an opportunity to get started in a safe way where they don't end up going down a path that is unproductive, so they can at least feel the enjoyment of making a contribution. So these are definitely the best ones to look at. A lot of the time, these are these are features kind of like at the exterior. So they're things like built-in functions that allow you to access some functionality in the Go standard library, or their feature or their changes in the documentation, which has its own separate kind of system, which I don't think we'll really get into that today, but we've got quite an elaborate documentation system. Or there are things to do with like operationalizing OPA. So when it comes to operationalizing OPA and deploying it, there are things you need to think about, like where policies are going to get pulled from, and where decisions are going to get logged to, and all that kind of stuff. And there's just a lot of different options for that. And so we've seen a lot of contribution in the past from users of OPA around those areas. So for example, when it comes to distributing policies to your OPAs, there's a bunch of different ways you can do that. You could put them on the file system, you could put them on S3, you could put them in GCS, you could put them on Azure. And then OPA, when it's pulling from S3 or from GCS, it needs to be able to authenticate with AWS APIs or GCS APIs in order to pull down those policies. And so we have I think 13 different ways of authenticating with different cloud service providers. And so all of those authentication methods have been contributed by users. So we see a lot of people making initial contributions for features that help operationalize OPA inside of their environments with their kind of unique tech stack, basically, right? Like some companies just have a very specific authentication system they're using, and it's not necessarily supported out of the box, but they can kind of make that contribution relatively easily. So that's kind of another area where we see a lot of contribs coming in.
Awesome, very helpful. Thank you. All right, let's move on to the fun bit then, shall we? We are going to contribute our own function to is it the OPA library, the Rego library? What would you call it? Rego library?
You're gonna contribute a function to the OPA language.
OPA language.
The Rego language. Yeah. You're gonna get to extend the language. So this will be fun. So yeah, there's two main directories that are involved in this. The first directory is the AST directory that you see at the top there. So the AST directory has sort of the implementation of the parser and the compiler for Rego. So it's all the code that takes Rego source files and then turns it into something that can be executed or evaluated, and kind of validates that it's valid, or validates that it's correct. One part of the AST package is that built-ins.go file that you see there at the top. So the built-ins.go file is basically a list of declarations for all the functions that are natively available inside Rego. And so this is just a list of the functions that are kind of registered statically. And you can see that there's functions for string manipulation, and regex, and all kinds of other things, like working with JSON web tokens, and working with Cedar blocks. And you can see we have a bunch of functions for dealing with data that's encoded, in JSON or base64, because sometimes people feed strange things into OPA and we need to work with those. We've got a bunch of stuff for crypto operations, and so on.
Wow.
And so
HTTP requests.
Yeah, you make an HTTP request. That's actually probably the most complicated built-in function in the library. There's things for checking do two network seeders overlap. Maybe that's interesting if you're writing policies over firewall rules and things like that, and so on.
But no string reversal.
There's no string reversal. There's also no string repeat, which I saw there's an open issue for. So if we wanted to change things slightly, we could do string repeat. So there's no string reversal though. So that's interesting. Maybe we need that. So this is the list of functions that are registered. If you scroll down further in this file, what you'll see are some variables, basically global variables that are declared. And you'll notice there's basically one for each built-in function in the language. So maybe scroll down a little bit. Let's find one that's not super generic. Any of those are good, actually. Multiply.
There we go. Multiply,
divide, multiply. Yeah. So this is basically like the declaration of the multiplication operator or function inside of Rego. What you see here is just like a structure that's being created, and there's some metadata on that structure, like the name of the built-in function. In this case, like multiply is kind of special because we have an infix operator for multiply, right? So you say, x asterisk y, that's x times y, right? So there's an infix operator. For the one we're going to do today, we won't have an infix operator. But if you're adding a new function that has an infix operator, you'd set that there. And then there's the actual function declaration itself. So that function declaration is basically like the signature for the function. And so we're basically creating a new function declaration that says that the multiply function takes two arguments, which happen to be of type number. Both of the operands are numbers, and then the result is also a number. So that's sort of how that reads there. And so in this file, I don't know, it's a few thousand lines long. It's like 1,500 lines long or something. There'll be one of these declarations for every single built-in function that's natively available inside of OPA. And so when you want to add a new built-in function, kind of the first thing you do is add the declaration for your built-in function into this file. It's worth mentioning that you can also add built-in functions from outside of OPA. So like if you are embedding OPA as a library and you want to extend it with your own custom built-in functions, you can totally do that. You don't have to like contribute them upstream. There's actually docs on the website that show how to do that. And so on. But for this purposes, we're gonna get a new built-in function into OPA. It's gonna be upstream, so it's gonna be great.
All right. So you mentioned when we were back at the top level, there were two directories we should look at. One was the AST, and the other is.
The other is called top down.
Top down. Does that mean something significant, or?
It's the name of the algorithm that's used for evaluating the policies.
Okay.
Yeah. And so inside of the top-down package, there are a bunch of files. You'll notice they have names that kind of look maybe kind of familiar. You see regex, you see strings, you see time, you see numbers and JSON. So most of these files contain the implementations of those built-in functions, right? So there's two parts to every built-in function. There's the declaration, and then there's the definition, right? So we just looked at the definition or the declaration. What we're going to look at now is the definition, right? The implementation of that built-in function. And so, for example, so you're in the numbers.go file right now. So this has a bunch of built-in functions for just kind of different numeric operations, not arithmetic, but there's you can open up arithmetic.
Okay, so I should have been in this file. There we go. There's multiply.
Yeah. So there's sort of the implementation for multiply. It's a little bit abstracted actually because if you go down a little bit, these are probably not the best ones to look at because we're using closures here, so it's like probably not the best thing for a new person. Well, hang on. Remainder. Okay, remainder is not too bad. So this is basically the modulo operation, right? So, maybe there's a simple one. Can you just go up?
Yeah.
Minus, that one's more complicated. Yeah, they're fine. Okay, so the way that these have been organized is that we've tried to avoid repeating ourselves a bunch. So we have built-in functions for like arithmetic functions that take one argument, and then built-in functions that take two arguments, and so on. And then they do a little bit of.
Should we jump into strings instead then?
Yeah, let's go to strings, just because I don't want to have to explain like functions returning functions for people. That usually trips them up.
All right, let's see if we've got replace.
Yeah, there's definitely replace. There we go. Okay, there we go. There we go. Now we're cooking. Okay, so this is like the implementation for the replace built-in function. And so what replace does is it takes a string, and it takes two strings and then a number. And so the first string is the string you want to replace inside of, and then the second string is the thing you want to replace to, I guess. Or no, sorry, it's three strings. The string that you want to replace inside of, the original value, and the new value.
So is this string operand function the way that we convert the AST value into an actual string?
That's right, yeah. So the built-in replace takes three arguments, A, B, C, and they're all of type AST value. So AST value is like an interface. It's a generic type for data inside of Rego. And so the underlying values for that are scalars like Booleans and numbers and strings, as well as comp collection values like arrays, objects, and sets. And there's a few other types, but for built-in functions, you only have to worry about those. You only have to worry about scalars and collections, arrays, objects, and sets. And so in this case, the string replace function it basically expects three strings. And so what we do is we take those operands and we just convert them we basically get the underlying string back from them. And so that's what that built-ins package exposes, is a bunch of helper functions for doing those kinds of conversions. And what that helper function really does mostly is it makes sure that there's a nice error message returned if we call the replace function with like a number or a set or something like that, where it wouldn't make sense.
Gotcha.
So yeah. So basically we convert those three operands into strings. And then what we do is we just kind of defer the actual implementation to the Go standard libraries. The Go standard library has a strings package, and inside that strings package, there's a replace function. And so we just pass in the three operands as Go strings. And then we take the result, which is itself a Go string, and we kind of convert that into we call it an opus string or an AST string, and we return that. So that's one of the, I guess, that's probably the most, that's sort of the most fundamental thing that has to happen with these built-in functions, is that like OPA is implemented in terms of its own value types. So OPA has its own type for string and number and so on. And so whenever we're implementing a built-in function, unless we're doing it natively on top of like those AST types, we need to convert them into raw Go types that we can call into the standard library or some third-party package or something like that.
Okay, so in order for us to implement reverse or repeat, we need to add something to the AST package, implement the function inside of the top-down package. I'm assuming there'll be a test we can work on, and then pull request. Nice and easy, right?
Yep. You missed one thing.
Oh, go. What I missed?
Documentation.
Oh, after you telling me your documentation-driven project.
It's okay. It's going to be one line in a markdown file. It's not going to be that bad. I promise. It won't be that painful.
All right. Where is the documentation at the top level? Will we take a quick look at that before we get started? Or
yeah, let's go back up. Yeah, we can look at the tests and we can look at the docs before we get started.
Okay.
So the documentation is under the docs directory. Surprise, surprise. Under content. And this is the documentation for the OpenPolicyAgent.org website, right? So when you go to OpenPolicyAgent.org and you click on the documentation, this is where it's all built from. Each one of these files basically corresponds to a page on the website. And so if you go to the policy reference one, this is the place where basically all of the built-in functions are listed. And so if you keep scrolling, there's a little cheat sheet at the top here that you're going through right now. If you keep going down, built-in functions. So then you see basically a list of all the built-in functions in the language and an explanation kind of what they do. And so we'll add a new one here. We'll add a new line to this table. We'll call it strings.replace or strings.reverse, sorry. That's really all we have to do. So we'll edit that file at the end. Not much to call out here. We kind of just explain what it does. That little column on the right, that indicates whether or not the built-in function is supported in our WebAssembly compiler, which we're not going to get into today. But we have a whole thing for that. And so those little check marks indicate that it's available out of the box with WebAssembly, which this one will not be because we're not going to have you write some C code for us today. But that's maybe the next episode is contributing on the WebAssembly side.
Exactly. There we go. Okay, so I've got my local clone here. I'm assuming we want to start off by creating a branch.
Sure.
Strings. You said there was an open issue for repeat, so let's just do repeat and see if we can get that working.
For sure.
I have my code editor here. I know all of the directories now. So, and you did say docs driven, so I will start with the docs.
Okay, I like it.
And we're going to open policy reference. I'm going to search for replace because I'm assuming my function will live next to that. And this is our string replace, right?
Yeah. Yeah, so just copy that line.
Yep.
And just paste it down, just create another one down beneath it. Call it repeat. Let's do, do you want to do reverse or repeat?
I'm indifferent. I don't mind which we do. So the Go API has functions for both, so I don't actually need to learn any code or write any code. So.
Oh, okay. Well, then let's do repeat and see if we can close out an issue.
All right. So I'll put it above replace because I'm assuming these are potentially alphabetical order.
Yeah.
Call this repeat. So this is just how it will look in the language where we say repeat the string that we want to repeat, and then the number of times. So this will be times.
Yeah.
Can I call that
and that seems good to me. The only thing I would say is one of the things we've learned over time is that it's better to like namespace these functions. So you'll see like strings.replace n. That's like a more recent one. We try to namespace all of them now, so let's call it strings.repeat to be consistent with the new convention. And then that looks good to me. And then we'll say output is a string that has been repeated times or something. I guess we could call it n times.
Oh yeah, times, and then okay.
Yeah.
And not WASM. So
yeah, and so then just say SDK dependent, capital SDK. Yeah, there we go.
And we have our documentation. There we go.
Nice. We have our docs. And so, yeah, actually, maybe I can show you a neat thing. One of the cool things that we do is that we have the website automatically built for pull requests. So if you want, you can just commit this right now, push it up, open a PR, and then we can see it on the website. And then we can, while that's building, we can just start working on the implementation.
Okay, that's what I expect. Docs, add strings, dot repeat. Are there any convention that people should be aware of, or with commit messages, or is it anything that explains itself goes?
I am very picky about commit messages. I think that there's a ton of value in commit messages, but and actually we mentioned some of that in the contributing.md file. Let's save ourselves some pain and just YOLO it. Just work, whip, hack, fix me, whatever. Like, let's just. I understand. We're busy. We need to get features committed. We don't have time to explain why we're adding this. So it's okay.
Okay. So I pushed this to my fork, so I can open that pull request now, and we should see the docs build is what you're saying, right?
Yeah. Hopefully the doc build is working. Yeah.
All right, so it looks like we got a bit of a template here.
Yeah. Most people just ignore that. Why would you read that? It's not.
There.
Perfect. All right. Now, as a reviewer, I have all the context in the world for why this is happening. So I'm thrilled. You'll see down below. Live on
Hold on to drop you in it too. So, what more context do you need? Oh, I never signed up.
We didn't sign off on DCO. I mean, we're cowboying this. It's okay. There we go. You've done this before.
I have indeed. Force with lease, never just force for anyone watching. Force with
Oh,
bad.
I just force. I'm an animal.
Okay, so that should satisfy the
So
VCO bot.
yeah, and so if you scroll down, so there's a bunch of things that are going to kick off on this. It's going to run tests, but which should just pass. But if you scroll down, there will be a Netlify. Oh, it's not
Not
there
yet.
yet. Okay,
Yeah.
just maybe I don't know, refresh, or maybe it'll come in a few minutes. Let me check on my screen. Here's where I learned that like Netlify is down or broken or something. I don't know why it's not there. Oh wait, first time contributors need a maintainer to approve and running workflows. 8 expected. Okay, approve and run.
Yes, you've got the new fancy GitHub thing that stops the crypto miners abusing the actions workflow.
Oh,
There we go.
all right. Well, I don't know. Why is the. Oh, now 9 are queued. Okay, hang on. I don't know why.
Well, we can give it a few minutes. Maybe it'll come in. Maybe it'll come in soon.
It might show up. Yeah, I don't know why it's not showing up right now. Okay.
So we added
Yeah.
our docs. So now we want to
Yep.
jump into the AST directory and add the definition for our new function, right? So
Exactly. Yeah. Yeah.
now, should I go into built-ins test first? Do I not have to worry about that?
You don't really need to add a test for the declaration because it's just basically data. So yeah, so what we'll do is just go down to the strings section, and we can add a new one in here, call it repeat, and then go down to where you find the replace declaration, and you can just copy one of those.
I should put it before replace n. I should keep the order.
Yeah.
All right, so repeats. There we go. A string n times. Is that enough? Can I just?
Yeah. Yeah.
You're just like,
I don't know if we're getting
whatever.
I don't know. I don't know if we're getting. I mean, yeah. If you're, yeah. No, yeah. That's fair.
I mean, we don't need to get this merged today, right?
I was gonna say I can't just merge this. I need like someone else to look at it because this is like conflict of interest.
Well, we could always compile it locally and use the REPL to confirm that it works, as well as our test case.
Oh, okay. That's what we'll do. Yeah.
All right, so we've got our new function, we've got our new object, dynamic. Okay, I'm lost. Do we need all of this?
No, we don't. So the repeat function is going to take a string and a number. So these arguments need to be changed, basically. So this, I guess this was a function that took an object. So instead of that, yeah. So we're going to take a string, I think, and a number in that order.
Like so?
Yep.
And that returns a string.
Yes. Yeah. Exactly.
Okay. And then do we go to strings.go? No. Top down.
Right. And so we registered it. We put it in the list above, right? In the.
We did, yeah.
Yeah. Okay. So that's cool. So now it's declared. So actually, what we could do now is build OPO, and we should be able to basically the policy. Like if you write a policy that calls strings.repeat, it should compile, but it won't evaluate. Like there'll be an error during evaluation. So let's do that. So let's get it building, and then we can just see that we can actually
go build, or should I use a make target?
Yeah, you can use a make target. So if you do a make build, that's what I usually do. That'll produce a little binary locally for you. And so yeah, okay. So you don't have Docker installed, which means we're just going to skip all the WASM stuff automatically. And
I hope it's a fast build.
Sorry, yeah, it's not too bad. Let's go.
At least it's not Rust. Rust compile times always infuriate me.
I feel like every time I try to, I mean, I don't use Rust very often, but whenever I do, I have to like update the version of Cargo that I have or something because some features being used that I don't have in my version. And yeah, the output's very pretty though. I will give them that. Okay, so they've learned from the Node framework.
Yeah. So when this finishes, we should be able to.
We'll be able to. refer to the function. So like if you type, like we'll go into the REPL and we'll type strings.repeat and it'll give us an evaluation error. It won't give us a compile error. It'll be like, yep, this compiles. It looks fine, but it won't evaluate. So did that come back now?
It has, yeah.
Okay, all right. So there should be a binary now called OpenDarwin AMD64 in your current directory.
There is indeed.
Yep. And so if you do like a version on that, it should have your commit. Yeah, so it's got the commit of the docs change, I think, and then it just says dirty because there's the uncommitted built-in declaration change. So yeah, so now we can just do an open run on that. Yeah, and so this drops you into the REPL, which I think we played around with this last time I was on.
I think we did. Yeah.
So this lets you just like execute policy queries and kind of experiment with them. So if you type like 1+1, it'll return 2, which is like a standard REPL. So now you should be able to call your string.repeat. And you give it a string and a number and Rego type error, undefined function. Oh, it's lowercase r. That's why.
Oh, yeah.
And so you see the error there was slightly different, right? So the first error was saying that there's a type error. It like didn't know about that function. The second error is saying that there's an internal error, unsupported built-ins. That's like, you would never see that normally because we don't obviously allow people to just commit declarations. But we can see now that it's compiling at least. And so if you call that with like flip those operands around, pass in the number first and the string second. So you get like a type error back now, right? So it's telling you there's invalid arguments. It was expecting basically a string, a number, and it would return a string. That's what that third operand indicates.
All right, nice. That's step one then.
Yeah, so cool. So we've got our declaration in. Let's go ahead and do the implementation.
Okay, so should we start with the test?
Well,
there is no test for strings.
Yeah, we'll talk about the testing, I guess, afterwards. It's going to be, yeah, it's data driven, so it requires a little bit of explanation. But yeah, let's just copy the implementation for replace, I guess.
This is how I do all my coding.
I just use GitHub Copilot now.
It's surprisingly good, I've got to say. Like,
I haven't tried it on OPA. I want to do that. I want to see if. Anyway, yeah. So delete that.
So this should be an integer, right?
Yeah. So there should be a helper function in there for numbers.
It's a times there. Well, let's see. We've got Copilot run.
Oh, wow. We're in the future, man. This is amazing.
Well, let's see if we can get the return statement. Come on, then.
Oh dear. Oh my God. We're going to be out of jobs pretty soon. This is ridiculous.
It's good. It is good. Anyway.
What is the type of times? I'm curious why it's doing a conversion on int there. Yeah, so it doesn't need to do that conversion.
All right. I think. You're rubbish.
Oh God. I can't believe they shipped that.
It was pretty close, I've got to say. I mean, all I typed was return, and it was like, here, this is what you want. So.
Yeah, these LGTMs are getting a lot easier, I guess. I think you might need that. Wait, okay. What is the? Yeah. Okay. And that's because S is basically an
AST string. All right. Okay.
Yeah. But the underlying type is a Go string, so you can just do that type conversion.
It's unused.
All right. It's unused, yeah. So the other thing we have to do here is register it, kind of like we registered it in the AST package by putting it into that list. There's a function down at the bottom of the file that we'll call in order to register.
Well, let's see. Oh no, you're wrong. I'm on Copilot. Don't make me actually have to learn to code.
And so there's basically different versions of this function for different arities. So like if you take one argument or two or three, so you got the two.
Yeah, it got it when I got to here. So I mean, it was still all right, I guess.
Yeah, and then it'll be a function. It just functional. Yeah.
Ah, no, it's rubbish. Okay.
Okay.
This should be.
Yep.
That it?
All right. That's pretty much it. So then let's build again and let's try it out in the REPL and see what happens. You can just go build if you want. It'll work. But yeah, you won't have like the version set and yeah, there's a few other things.
Yeah, it's doing the go generate first as well. So.
Yeah. WebAssembly won't be enabled. What else? Oh, you don't actually have to have Sego enabled. You can build with Sego disabled if you want. But yeah, it's on right now because of our WebAssembly runtime that we're using.
All right, so we're going to go back into our run.
Yep, and if you just go up, even it should just remember. Yeah.
Well, that's the broken one. But
that's the broken one. Oh. Yeah, you go up multiple times. Yeah, whatever.
You need to integrate Copilot into the repo now, please.
Oh no! Now my days. I had stuff I wanted to do today, but yeah.
There we go.
All right, there we go. Very cool.
Oh
no! So better.
Should we add some input validation?
Yeah, we should check that. I guess. What happens if it's empty? Can you go back? What if the string's empty?
Oh, that's the wrong way. Okay. But it didn't save my history when it crashed. Rude. Okay.
Okay, and what about 0? If you do 0, does that panic? No. Okay, all right. Well, that kind of makes sense, I guess. Okay.
We're finding loads of edge cases in our simple function now. So.
Yeah, we thought this was going to be easy, and we were wrong. It's like all software. Okay, so we just have to check for negative integers.
Oh, I shouldn't have moved. Built in repeat. Built in. Okay, so we're going to say here that if it can't convert or if time. Oh, thank you, Copilot. Return. Is it going to give me an error message? Oh.
Yeah. Oh my. Okay, this is insane. You're just like, are you working for GitHub now, David?
I have it enabled. Like I said at the start, I've been very impressed with it. It does know what I want to do most of the time. Okay, I think that's much better. Let's do one more build, and then we will look at. Do you want to look at the testing just now?
Yeah, we do that. Yeah, I mean, I'm pretty sure that's going to be the right thing. So for testing, we have sort of like a data-driven approach for these, especially for these built-in functions. Under the test directory at the top level, let me just double check on that.
Yep, we got a test here.
I haven't implemented a built-in function in a while. Test.
I think I found it. So it seems to be under cases.
Yeah. So each one of these directories maps to like a category of tests, basically. There should be one called strings. Yeah. These have horrible names because they were generated from Go code originally. So we anyway, it was a whole thing.
So are we adding test string 0924.yaml? Or
well, we can add test strings repeat, I think. And perfect.
Repeat.yaml. All right, and I should probably take a look at one of these.
I don't remember the so there's a bunch of garbage data in here because they were auto-generated, but we can just copy that whole thing. Actually, that index of Unicode, that's probably got a cleaner example. Yeah, there we go. Perfect.
If I just copy one of these modules, and then
let's do 2 of them. We can just do one for now, and then we can just get that test. We don't have to do too many tests.
I mean, we copy and paste the test, but if we copy one, we've got a baseline.
Let's just make one test, and we can push that up, and then we can call it at that point. So let's just add a test. Strings.repeat. And so let's repeat a string. Oh yeah, this says Unicode. Yeah, interesting. Okay. I think someone tried to do this a little while ago. They tried to contribute this and they ran into Unicode problems and someone rejected it. So we might I might have picked a bad one because we might get our PR rejected too by Stefan or something. So then that looks good. So basically, what this is saying is there's the module is like a Rego file. Okay, so this is like just like a kind of like a test fixture, right? So it's just like it's like a Rego file for test purposes. And so all we're saying here is there's a rule called the P, the letter P, and we say P is equal to X if, and then it's just saying like strings.repeat lgtm2. And what we'll want to do is assign X inside of that rule. So we want to say like X equals strings.repeat on line 7. Otherwise, X will not be safe and we'll get a compiler. Yeah, that'll do it.
Okay, so can I make tests or?
You can, yeah. If you go back into your terminal, if you do make test, it's going to run all of the tests. And so that'll take probably longer than we want. I think, so what you could do instead is just go test on the top-down directory. And that should only take a couple seconds. Okay, so that completed. So all the tests passed, took 4 seconds. What we need to do though is get the name of this test so we can just kind of like look at it. Oh, okay, yeah, you can just rerun them all.
I never trust a test that passes first time, so.
Yeah, no, that's perfect. So then what I would do at this point basically is I would take that test. So you can see the name of the test there. So you can see like test Rego /strings repeat normal case. So you can just run that specifically if you want. So you can say go test dash run or top down run, doesn't matter, and then pass in that name.
Oh, like that.
Mm-hmm.
Okay.
And now it'll only run that specific test case.
All right. So let's test that our negative works. Can we? I guess I can just run it and see what happens.
Yeah. So the negative, what that's going to do basically is like if you call it with a negative value, it's just going to be undefined, so it'll have no value, right? So what we're going to want here is for an undefined result. Let me look up what we have to do for that. If you go into the REPL, you'll see what I mean.
Oh yeah, we haven't actually ran that again here since. Result. Undefined. Okay.
Yeah, so what we're going to want is basically an empty list, I think. I can't remember the... Yeah, you'll want that to be an empty array, I think. Basically, that means like there's no results, basically. Like there's no values that satisfy the query. Here we go. Oh, wait, no test to run. Yeah, just do like strings repeat and it'll run all the strings repeat. Like you don't need to that thing on the end.
Oh, it worked. It passed.
Cool, and it ran both of them. If you do -v, you will see that it ran both. Oh, you just did all of them. Yeah, you could do like -run up to repeat, and then specify -v. Yay! All right, here we go.
Ship it.
Ship it. All right. So commit that, and hopefully the website. Yes, it has. Okay, I'm gonna just grab this link quickly. Okay. Yeah. So when you, just go ahead and commit that.
Perfect.
Yeah. I think you'll probably see that in that PR, there's going to be a file called capabilities.json that was edited. If you go up to files changed.
I did notice this when I did my get -p, and I just
Yeah, you just trusted the process. Yeah. So what that file is it's like a data file that has a list of all those built-in functions in JSON. And so that's a feature in OPA where you can kind of like restrict what functions are available. We publish that, so it's available. There's a directory called capabilities in the repo that has for every version of OPA, like what language capabilities are available, basically. So now It's rebuilding again, but I actually got on there before it started rebuilding, and I grabbed the link to the Netlify preview. So I'm going to post a comment.
Oh, we got a celebration already. Thanks.
All right, all right. Oh, Bobcatfish. She's watching. Okay. Bobcatfish is one of the Tecton co-creators. So we've got some famous people on here. All right.
So this is the documentation that was built as because of our.
Yeah. So if you go to, so this is basically a live preview of the website. You can go over the docs. The docs are versioned. So if you click on reference right now, you're not going to see your built-in function because this is the docs for 30.2. But you can get the Edge version down at the very bottom. And so this is the next release, and there we go. All right.
Perfect. That was very cool. We have cloned OPA, built it, tested it, used a REPL, added a function, added a test, miraculously got the undefined. Yeah, I don't know how you pulled it out of your head or you looked it up, but all good. And the pull request is pending. Now, I'm sure we can clean this up, get a proper review into stuff later, but that was a great introduction to contributing to OPA. Thank you so much, Soren.
Thanks, David. It was a pleasure. We're going to have you back to write some C code for us because we need built-in functions.
All right, we're going to be doing LGTM WASM OPA edition soon, I am sure.
I can't wait.
All right. Thank you again. That was an absolute pleasure. I hope the people watching got a lot of value out of this. Please check out OPA, contribute, get those pull requests in. And any last words from you, Torin, before we wrap up for today?
Nope. I'll just say that we're always looking for contributions. So if you're interested in the project, check out those good first issues, or check out some of the integrations like Gatekeeper and ConfTest and the Envoy plugin. Or if you have ideas for other integrations, we're always interested in that. So please do reach out.
All right. Awesome. Thank you. But again, thank you. Have a great day. Have a great weekend. And I'll speak to you again soon. Bye all.
You too. Take care. Bye-bye.